The global transition to offshore wind and subsea power transmission is colliding with a fundamental material limit. High-voltage direct current projects require specialized insulation to withstand extreme dielectric stress. By 2026, global demand for extra high-voltage grade cross-linked polyethylene will reach 235 kilotons, far exceeding the projected global capacity of 145 kilotons. This structural deficit emerged in 2022 when demand first outpaced manufacturing capacity. Consequently, lead times for subsea cables have expanded from 15 months to 60 months. Grid operators can no longer secure timely delivery of critical transmission assets. The supply of this critical polymer is highly consolidated. Two chemical conglomerates, Dow Chemical and Borealis, control 86% of global capacity. This extreme concentration leaves the entire global offshore wind pipeline vulnerable to localized industrial disruptions. Entering this market requires massive capital and highly specialized technology. Production requires cleanroom polymerization and advanced multi-stage filtration systems to eliminate microscopic impurities. A single contaminant particle larger than 70 microns can destroy a subsea cable. Engineering trends are compounding this material bottleneck. To reduce transmission losses, operators are shifting from low-voltage lines to 525 kilovolt systems. This transition increases the required insulation mass by over 200%, demanding 1,900 metric tons of polymer per 100 kilometers. At these higher voltages, dielectric stress reaches 20 kilovolts per millimeter. Any microscopic defect triggers electrical treeing, causing catastrophic subsea failure. This physical constraint mirrors the 19th century reliance on gutta percha, proving that modern high-tech grids remain bound to obscure, single-source materials.